Complementary events. Just some revision. When calculating probabilities, remember that the probability of the event equals number of favourable outcomes over total number of outcomes, or number of favourable outcomes divided by total number of outcomes. And probabilities can be presented as fractions, decimals, or percentages. Let's have a look at an example. Calculate the probability of rolling an odd number on a six-sided die as a fraction, decimal, and percentage. So, as a fraction, we have the probability of odd equals, there are 3 favourable outcomes over 6 possible outcomes. So that equals 3 over 6, which equals 1 over 2 or a half. As a decimal, the probability of odd will equal 0.5. And as a percentage, the probability of rolling an odd number will equal 50%. Today's learning intentions are we are learning to identify complementary events and use the sum of probabilities to solve problems. Our success criteria is you will be able to establish that the sum of the probabilities of all of the possible outcomes of a single-step experiment is 1. You will be able to identify and describe the complement of an event. You will be able to establish that the sum of the probabilities of an event and its complement is 1. You will be able to calculate the probability of a complementary event using the fact that the sum of the probabilities of complementary events is 1. So, complementary events. Complementary events are 2 outcomes of an event that are the only 2 possible outcomes. The probabilities of complementary events add up to 1 or 100%. E comma is set notation for the complement of E. So we can see that the probability of the complement of E equals 1 minus the probability of E. And where the probability of the complement of E is the probability of E not occurring, or the probability of the event plus the probability of the event of the complement of the event equals 1. Now, a lot of that probably won't make sense to you, but as we do examples, I'm sure you will learn. So let's have a look at an example. Rolling a 6 on a fair-sided die. Now we know that the probability of rolling a 6 is 1 over 6. 1 favourable outcome over 6 possible outcomes. Now when we want to find the complement event to rolling a 6, it is simply the probability of not rolling a 6. And the probability of not rolling a 6 is 5 over 6 because we could roll a 1, a 2, a 3, a 4 or a 5. So that's 5 out of 6 possible outcomes. And the 2 events add up to 1 because 1 over 6 plus 5 over 6 equals 1. So when you're looking at complementary events, the probability of the event happening and the probability of the event not happening adds up to 1. Let's have a look at another example. If the probability of it raining tomorrow is 20%, what is the complement of this event? So we're looking at the event raining tomorrow. So it's going to be not raining tomorrow. So the probability of it raining tomorrow equals 20%. The probability of no rain tomorrow or it not raining tomorrow is 80% because 80% plus 20% equals 100%. And if we just have a look at another example, from this coin collection, a coin is to be chosen at random. We know some probabilities already. The probability of an Australian coin equals 1 over 4. The probability of a Chinese coin equals 3 over 800. The probability of a British coin equals 1 over 8. The probability of a Singaporean coin equals 2%. The probability of an African coin equals 3 over 20. The probability of an American coin equals 21%. Find the probability that the coin chosen is not Australian. Okay, so if we know that the probability of it being an Australian coin is 1/4, then this is a complement event, a complementary event. So we need to do 1 minus 1/4 equals 3/4. So the probability that it is not an Australian coin equals 1 minus 1/4, which equals 3/4. If we have a look at not British, so we can see that the probability of it being a British coin is 1/8. So this once again is a complementary event. So we go the probability of not British equals 1 minus 1/8, which equals 7/8. And lastly, the probability of it not being an American coin. We know that the probability of it being an American coin is 21%. This is also a complementary event. So the probability of it not being an American coin equals 100% minus 21%, which equals 79%.